Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Firdaus Zawawi. So today I will share with you about one topic, firing of traditional ceramic. So basically, bila kita sebut firing of traditional ceramic, the process that occurs inside the firing is sintering basically. So the word sintering itself shows that the powder particles of ceramic, it will turn to the solid, which means that in terms of powdery of ceramics, it will become a solid as shown in the picture. The first step, the pores is big, and when the sintering process, the pores become small in size. So that means the sintering process. So basically, the sintering process kita akan buat dia dalam furnace. Dan furnace yang kita buat ni, kita panggil dia kiln, K-I-L-N. And basically, dalam furnace ni, kita akan panaskan ceramic powder tu sampai 900 degree Celsius. So basically, apa yang berlaku dalam proses firing of traditional ceramics adalah, kan tadi kita ada powder particles kan, which is in terms of powdery. So di antara powder particles tu, we have a space that we call it as pores. So setiap powder particles ada pores. Dan bila sintering proses, kita heatkan powder tu, kita firingkan powder tu, the pores will become small. And lastly, apa jadi kat powder tu, dia akan jadi satu solid. So the factors that contributes the bonds developed between ceramic grains, we have two. The first one is densification, di mana density, asalnya density dia mula jadi macam ni dan sekarang jadi solid. Dan yang kedua, reduction of porosity, di mana kan size pores dia besar. Lepas tu lepas kita buat sintering, size dia jadi kecil. Sebab tengok gambar kuning ni, nampak tak yang hitam-hitam ni semua pores dia. So after kita sintering, pores dia semakin kecil dan semakin hilang, dan ceramik tu dah jadi solid. So sebenarnya dia akan berlaku shrinkage tau. Additional shrinkage occurs in the polycrystalline material. So bila kita panaskan powder tu, dia akan sinters, dia akan jadi solid. Di mana kalau tengok ni saiz kuning-kuning jadi besar kan. Bila lama-lama dia akan jadi kecil sebab dia shrinkage. Satu analogi yang saya boleh kaitkan dengan atlet-atlet kan. Contohlah, kalau kita naik kapal terbang, lepas tu kita terhempas dan kita akan jatuh dalam air. So manusia sendiri, apa yang berlaku bila dia jatuh dalam air adalah air akan masuk dalam badan, which is air kita akan jadi besar. Dan lama kelamaan, bila kita diangkat, air akan keluar, di mana proses shrinkage daripada kita jadi besar kepada kecil. Macam tu juga dengan ceramics, dia boleh shrinkage. Okay, the next thing is shrinkage during sintering. Sama juga macam yang saya dah terang tadi. So kalau tengok kat sini, this is in terms of powder. Nampak tak powder? So bila shrinkage ataupun sintering, dia akan menjadi compact. Powder tu akan rapat sampai jadi bentuk solid. So ni explanation lagi. What is sintering? So, sintering is a process di mana powder compact is transformed to a strong, dense ceramic body by heating. Maksudnya, kita panaskan powder tu sampai dia akan jadi strong, dense ceramics. Dan apa yang berlaku sebenarnya, kita akan eliminate pores. Kan tadi ada gambar kan, pores yang besar jadi kecil. So dengan masa sama, kita akan eliminate pores tu, kita compresskan dia jadi solid. So dalam pada masa sama, bila kita eliminate pores, akan ada binding, akan ada bond between grains. So apa faktor-faktor yang mempengaruhi sintering ni sebenarnya? Dia bergantung kepada initial grain density. Maksudnya powder starting material kita ni, initial grain density refers to the ratio of metal powder volume to the external volume. Okay, maksudnya initial kita punya starting material. Dan biasanya sintering akan berlaku 15 hingga 30% secara linear. So, apa masalah yang kita hadapi ketika shrinkage during sintering ni adalah the problem in predicting the final size and shape. Sebab kita tak tahu macam mana size dia, macam mana shape dia lepas kita buat sintering. Jadi, satu cara macam mana kita nak control dia adalah kita gunakan lubricants. Because lubricants can give good flow in compaction. Okay. Next, sama juga saya akan terangkan tentang refractories. Group sebelum ni pun dah terang tentang refractories. So kita nak recap saja. So this is a refractories. Okay. So macam group sebelum ni pun dia dah terang what is the characteristic of refractories. So boleh baca dia tahan terhadap suhu yang sangat tinggi, dia tak akan cair ataupun decomposing, dia tidak reaktif dengan bahan yang kita bakar. Remain unreactive. So material contents pun sama macam group sebelum ni explain. Okay, ni saya nak tekankan tentang refractories materials. So apa bahan-bahan yang kita gunakan dalam refractories? Apa faktor-faktor yang mempengaruhi refractories? Yang pertama adalah depends on porosity. So boleh tengok kat gambar ni, kat A ni porosity dia sangat tinggi. Gambar B ni small in pores, maksudnya dia low porosity. So apa kaitan refractory materials dengan porosity? So in refractories, porosity refers to the pores on the surface or open pores. So maksudnya untuk kita buat refractories ni, porosity ni sangat penting sebab dia akan efek kepada properties of refractories tu sendiri. Antara kesannya adalah slag resistance. What is slag resistance? Slag resistance ni adalah the capacity of the refractories materials to counter the destruction action of molten slag. So actually ada kebaikan dan keburukan bila kita buat high porosity and low porosity. Antara kebaikan bila kita buat high porosity adalah sebenarnya bila high porosity dia excellent, insulating properties dia akan jadi bagus. Tapi dia low density sebab kita high porosity. Dan bila dia low density, dia low juga corrosion resistant. So bila dia low corrosion resistant, dia akan low strength. Tu bila kita guna high porosity. But if we use the materials with low porosity, dia akan improve strength. Okay, dia akan improve strength. Dia akan juga improve corrosion resistant at low in thermal shock. Okay, so as a result, the amount of porosity it depends on the specific service. So tengoklah kalau kita nak buat tu, kita nak thermal shock yang tinggi ke yang rendah, so it depends. Okay, in high and low porosity. The next factors is less thermal expansion. Kalau tengok kat sini, nampak tak yang atas ni bila kita gunakan alumina, kan ada kan material content alumina, dia boleh tahan sehingga 2050 degree Celsius. Tapi kalau metal, dia tak tahan sangat. Jadi kalau tengok expansion dia, nampak tak yang kecil atas ni? Kalau alumina, dia lambat untuk dia expand. Tapi kalau metal, dia cepat expand bila kita give heat yang tinggi. The next factor is resistance to thermal shock. So kalau alumina, kan nampak tak yang ni, yang alumina ceramik kan, dia resistant to thermal shock sampai dia boleh lebih daripada 500 degree Celsius. Dia boleh tahan dengan suhu yang panas. Tapi kalau original material, sehingga 200 ke 300 degree Celsius sahaja. Selanjutnya increase insulation. Kalau kita guna material content refractory ceramik yang bagus, dia akan keep temperature dalam suhu yang kita nak. Maksudnya tak ada haba yang keluar. Dia akan keep kita punya proses dalam temperature kita nak tu. And the last one is lighter. Okay, so the disadvantage of refractory ceramic, the resistance to chemical attack and weaker load bearing capability. Okay, second section.
I am Iffah Nabilah and I will explain about the application in refractories. So there is in this slide I will explain about the phase diagram. So we can see here that at the y-axis there is temperature, and at the x-axis is the composition of alumina. So refractories are used in furnaces, and of course the characteristics of refractories is to resist high temperature. So there is at certain composition of alumina and at certain temperature there is suitable refractories that can be used in furnaces. So at the first part there is cristobalite with liquid, so it can be used as refractories because it is not solid enough. So at this beside the part is molite and with liquid. So this material can be used as refractories also, but at this part, the blue one, with about the composition of alumina is about 77% and the temperature is above 1400 degrees Celsius. The molite can be formed, and this molite will be used as the refractories. So other than that, they are not suitable enough to be used as the refractories, and also it is not solid enough and will mix with the liquid also. The step for processing of new ceramics, there is 4 steps, which are preparation of starting materials, shaping, and then sintering, and lastly is finishing. For the next slide, about the preparation of starting materials, strength requirements are usually much greater for new ceramics than for traditional ceramics. So what is the example for new ceramics, such as artificial bones, cutting tools, nuclear fuse substrates for electronic circuits, and many more. So you can see here at this side of the slide is artificial bones, and also the electronic circuits that are made from ceramics. And traditional ceramics such as pottery, such in the picture, and also like porcelain, bricks, and many more. Powder preparation includes mechanical and chemical methods. So to prepare the ceramics, we need the powders that must be smaller and more uniform in size, because it will be processed and become more solid. And the example of raw materials for traditional ceramics such as clay minerals, and if nowadays the advanced ceramics that is used as the raw materials is silicon carbide. The next slide is about the next step on processing the ceramics is shaping step. So the most important thing that we know is the 2 steps that are used to shape ceramic is hot pressing and also powder injection molding. So, how is hot pressing used to shape the ceramics? So, what is hot pressing? So, it is similar to dry pressing except it is carried out at elevated temperatures. So, sintering of the product is accomplished simultaneously with the pressing. So, I will show you the next slide. How is the picture of hot pressing? So this is how the hot pressing. So the raw materials will be inserted in this area, and there is the pressure from upper and lower will compress the powder, and also the heater at both sides. So the powder will turn into solid, and this is why the sintering process is also accomplished, because the heater will also sintering the solid inside this area. So the other example for shaping the ceramic is powder injection molding. So the ceramic particles are mixed with a thermoplastic polymer and then heated and injected into a mold cavity. So the polymer will act as a carrier and will make the raw materials flow into the mold. So when upon cooling, which hardens the polymer, the mold is opened and the part is removed. So the plastic binder is removed and the remaining ceramic part is sintered. So how is the powder injection molding look like? So this is how the powder injection molding look like. So the raw materials will be mixed with the binder and also additives. So the additive is such as color that will give some texture to the ceramics. So it will be mixed together and it will form into granules and it will inject into the injection molding so that it will get into the shape that we want. And also when the debinding process happen, the sintering process will be happen next, and we can get the final product that we want. So the binder that we add at the first will be removed before we achieve the final product. That's all.
Okay, now we are going to talk about advanced ceramic material. Why do we want to use advanced ceramic instead of traditional ceramic for a modern industry? Because advanced ceramic material make application possible because of their unique material properties. Since, as you can see in the slide, they are harder, stronger, and they can resist heat, temperature, and corrosion much better than metal or ceramic. I have classified advanced ceramic into 3 categories: oxide ceramic, non-oxide ceramic, and composite. Oxide ceramic consists of zirconium, aluminium, whereas the non-oxide ceramic are from the example silicon carbide, silicon nitride, boron nitride. Whereas composite is a category of advanced ceramic where it is the combination of the oxide and non-oxide. The main difference between the traditional ceramic and advanced ceramic is the material. So, mainly the traditional ceramic is made out of what material? Clay. So, by advanced ceramic, we make it mostly out of oxide, nitride, boride, and carbide. Other than that, the difference is the process. Traditional ceramic is easier to make and we can shape using hand, like for example the plant vase, whereas the advanced ceramic we can make the chemical composition and crystal structure like how we want to. And there are a lot of applications such as cutting tools, dye blanks, wear resistant parts and coating, oxidation barrier, high temperature component. Next, we are going to look at the application. In engineering, we use it in the automobile engines, especially in the internal combustion engine. We use it for the engine block, the coating of the piston, jet engine. Just now, we already saw the different categories of the ceramic, the oxide, non-oxide, and composite. But this automobile engine use the third category, where we use the oxide and the non-oxide. We use the advanced ceramic because we can increase the fuel efficiency. There is a lot of advantages. The main advantage is because it can withstand high temperature than metals, and it has a high wear and corrosion resistance. As you can see from the image, the engine parts uses a high temperature to increase the fuel efficiency. So that's why we need to use advanced ceramic. Did you know that metal can withstand up to 726 degrees, but the advanced ceramic can withstand up to 2726 degrees. That's why we need to use the advanced ceramic because the temperature to make it efficient is high. Other than that, it is low coefficient friction, able to operate without a cooling system, and it has a low density and lower weight than the current engines. Which means, if it's lighter, that means the speed is higher, right? There is also a disadvantage. Advanced ceramic are brittle, easy to have voids, and difficult to form and machine. This is because we need to make a lot of layers for it to work. That makes it has a high initial cost to make the shape and layers. That's why the industry always makes a special precaution and checks each of the components so we can use it in the optimized performance. Next is the application in ceramic armor. As our friends in the previous group has mentioned before, we use advanced ceramic in armor because it is lighter than metal. Oh no, it's lighter than steel but harder than metal. As we know, they have two layers. The outer facing plate is for the shattering of the high velocity projectile, whereas the backing sheet is soft and ductile to absorb the energy. This is why we say they have attenuative property, which means it can absorb the force. The commonly used ceramic is aluminum oxide, boron carbide, silicon carbide, and also titanium diboride. So I will show you some example of vehicles and clothes that uses the advanced ceramic as an armor. We don't only use it for the shield, but we use it for the tank and also the vest because it can absorb the energy and it's hard to break. So that is all from me. For my part, I will further explain about application of the ceramic. Die blank. Die blank is what is die blank? Die blank is benda yang kita guna untuk pegang sesuatu yang kita nak potong. So die blank dia perlukan need wear resistant properties untuk bagi tahan lama, tak berkarat apa semua tu. Lepas tu die surface, how it made, 4 micrometer polycrystalline diamond particle that are sintered onto a cemented tungsten carbide substance. So polycrystalline diamond ni dia help to control the fracture and give uniform hardness in all directions. So dia sangatlah kuat nak pegang material untuk potong tu. Okay, for cutting tools, user dia for blending glass, tungsten, carbide dan seramik. For cutting silicon wafer, benda-benda yang keras, kita gunakan seramik untuk potong macam silikon. Lepas tu for oil drilling, untuk gali minyak bawah tanah yang keras, so kita guna seramik juga untuk gali. So how it made? Manufacture single crystal or polycrystalline tu crystal diamond in a metal or resin matrix. Optional coating. From as you can see from the slide, oil drilling bits ni dekat dia punya hujung tu kita gunakan seramik yang kuat, coating. Try to help diamond bond to a CO matrix via alloying. Polycrystalline diamond resharpened by microfracturing along crystalline plane. Okay, for this part is oxygen sensor. Oxygen sensor is made of ceramic also. So ceramic sensor ni dia ada dekat dalam kereta. Dia akan cooperate with the engine to make sure that your car is at top performance. So how it function? Oxygen sensor dia akan send data to the mainframe computer dalam engine tu. So macam mana dia punya mechanism is when from the diagram you can see that gas from the daripada luar dia akan diffuse masuk ke dalam sensor ni. So the external surface sensor to be the reference of the sensor to the referent gas. Lepas tu daripada situ dia akan hasilkan voltage yang akan hantar kepada management komputer. So dia akan tafsir lah macam tu. What happen when if more oxygen present? So dia akan, kalau more oxygen present, dia akan rosakkan engine tu. So dalam nak bakar gasolin ni dia ada ratio yang ditentukan untuk digunakan untuk bakar gasolin tu. Kalau lebih, dia akan hasilkan benda lain. Dia akan hasilkan benda yang akan pollutant lah, akan cemarkan alam. Okay, so then let's proceed the presentation with the electronic application of ceramic. There are three examples of the electronic application, which is insulator, sensor, and also capacitor. The insulator, which use the material that we use in the insulator is alumina, beryllium oxide, boron nitride, silicon carbide, and aluminum nitride. For the sensor, we use zirconia, and for the capacitor, we use barium titanate. Okay, for the insulator, as I said just now, that insulator we use boron nitride, silicon carbide, and aluminum nitride, which is this all material is the ceramic material. And for the insulator, it used for support the weight of the suspended wire without allowing current flow through tower to ground. As we know, the insulator we use, we can see the insulator on top of the transmission tower in electric tower, because it is resistant to the current, so the current will not flow through it and not through to the ground. Why the ceramic material is used? Because it high resistant to current and non-metallic material and non-conductive, so the voltage cannot through it. And this is the comparison between ceramic and porcelain insulator. For the ceramic and porcelain, ceramic is lower price than the porcelain, and ceramic can chip or break in cold weather, but the porcelain can withstand harsh weather. Ceramic can be better than the others insulators such as plastic insulator, glass insulator, and wood insulator, but the porcelain will be better insulator than ceramic. That's all. Thank you.
So my name is Huzairie Iskandar and I will talk about CMC. CMC stands for Ceramic Metric Composite. Ceramic metric composite is a subgroup of composite material as well as subgroup of ceramic. They consist of ceramic fiber embedded in the ceramic matrix. So we can see here is a sub ceramic fiber and the outer layer is ceramic matrix. So it is invented to overcome all the problems come from ceramic. So as we all know, ceramic is easy to crack, brittle, and many more. So the difference between ceramic and CMC is CMC is a mixture of two or more elements, generally two element, but ceramic only consists one, which is one element. So the ceramic consists matrix, which is the main element, which hold the second element, which is we call it reinforcement to increase the strength of the matrix. So all this CMC can overcome the problem from the ceramic, which is alumina, silicon carbide, or zirconia. Okay. And here we can see the example for the CMC that usually used in the industry. We have silicon carbide, alumina, and malt, and most commonly used fans. So for the next advantage of CMC, okay, the first thing is CMC is to overcome all the problems from the ceramic. So first thing is the advantage of CMC is it can increase the crack resistance and toughness. So CMC is more tough and hard to crack. For the second one is increase the elongation and thermal shock resistance. Thermal shock resistance is which it can uh, it can hold up in a high temperature when it gives a high temperature, so it can hold it not easily to break. Next is CMC, I believe to be toughened by three main mechanisms, which result from the reinforcement fiber interfering with crack propagation in the ceramic as follow: ceramic deflection. So for the ceramic deflection, we can see like tempered glass. If we give a pressure, it will deflect, so the crack will not happen. So that's mean by the crack deflection. It will deflect all the crack. For the second one is crack bridging. Crack bridging, fibers can bridge the crack and help to keep material together. So it will increase the stress level of the CMCs. So higher stress level needed to crack the CMC. And the last one is fiber pull out. So what I mean by pull out? The friction caused between the fiber being pulled out of the cracking matrix absorb energy. So higher stress are needed to produce further correction. So for the next, so the manufacture of CMC. The first one is layup and fixation of the fiber shape as the desired component. The second step is infiltration of the matrix material, and the final one, final machining, and if required further treatment like coating or impregnation of the intrinsic porosity. So infiltration, where the ceramic fiber will put in the ceramic matrix to make it as CMCs. Application for CMC is first is heat shield system for space vehicle. It is because when we enter the atmosphere, at there it has a higher temperature and higher pressure. So when we use CMC, it can overcome all the pressure and temperature, so it not easily to crack. Understand? Second one is component for high temperature gas turbines such as combustion chamber and turbine blade. So for high temperature, CMC can hold up temperature in high temperature because it has a short thermal. For the third one, component for burners, flame holders, and hot gas ducts. So it's also same with the second application, which CMC have a great thermal shock. And the last one is brake disc and brake system component. It's also same with the second and third one, which CMC can experience an extreme thermal shock. So I think that's all from me. I hope you can understand what. If you don't understand, you can ask me later. So thank you.
So today I'm going to explain to you about cement and concrete. So what is cement? Cement is a mixture of compounds made by burning limestone and clay together at a very high temperatures, which is 1400 to 1600 degrees Celsius. Okay, and Portland cement. Portland cement is the most common type of cement in general used around the world as a basic ingredient of concrete. The major constituents of Portland cements are tricalcium silicate and dicalcium silicate. So what is concrete? Concrete is a composite material consisting of aggregate particles, sand and stone bound together in a solid body by a cement. This means in a concrete, it consists of cement, aggregate particles which is sand and stone, and also water. Cement plays a role as material that needed to combine these aggregate particles to form a concrete. This is the picture or the comparison between cement and concrete. We can see the cement part. Cement part is actually just like a powder, a silver powder. And the concrete, it is the texture is a bit rough because it contains aggregates such as sand and stones. This aggregate will be combined with cement and also water to form concrete. In this topic, the roles of water are very important. Okay, why? Water is the key ingredient which, when mixed with cement, form a paste that binds the aggregate together. When the water mixes with cement, it will form a paste in liquid form that binds the aggregate together. The water causes the hardening through a process called hydration. As we can see here, this is the chemical reaction that happen when we want to make a concrete, which is tricalcium silicate plus water, calcium silicate hydrate, which will form calcium silicate hydrate, and calcium hydroxide, and also heat. Water plays a critical role, particularly the amount used. Why? Okay, uh, let me tell you briefly. Water, the strength of concrete depends on the amount of water used. If we use the amount of water a little, the strength will depend on the amount of water. Okay.
So we move to the next topic, which is strength of concrete. The strength of concrete is very much dependent upon the hydration reaction. Concrete is actually mixed with more water than is needed for the hydration reactions. This extra water is added to give concrete sufficient workability. Concrete need sufficient workability and also high strength. So, to get the sufficient workability, the concrete need extra water. The water not consumed in the hydration reaction will remain in the microstructure pore space. This means when we put extra water, the excess water that will not consume will remain in the microstructure pore space. This statement will be explained in the pictures next. Okay, these pores make the concrete weaker due to the lack of strength-forming calcium silicate hydrate bonds, which means, okay, this is the pictures. As you can see here, this is the picture of low water cement ratio, and this is high water cement ratio. Okay, cement particles suspended in mixed water. Okay, you can see here the space here, we call it as pores, and when we put too much water, the water will stay in the pores, so there is lack of silicate hydrate bonds. So this will make the concrete less strength but sufficient workability. Okay, you can see here when the concrete has low porosity, it has high strength, and when it has high porosity, it will have low strength. Okay, this is the graph to relate between the water cement ratio and also the cement content. As we can see here, for the number 1, water cement ratio, when the water increase, the strength decrease, and when the cement content increase, which is the level of water increase, the constant workability also increase. Okay. The conclusion is here. Low water to cement ratio leads to high strength but low workability. High water to cement ratio leads to low strength but good workability. Okay, what is admixtures? Admixtures are substances other than the key ingredient, which is cement, aggregate, which is stone and sand, and water, or reinforcements which are added during the mix process. Some admixtures add fluidity to concrete while requiring less water to be used. By the means of some admixtures, the one of the admixtures that been used to make the concrete more strength but required less water is superplasticizers. Superplasticizers increase strength the concrete by decreasing water indeed for workable concrete such as special polymers. Okay, admixtures will make the concrete more workable or fluid without adding excess water. So this is the pictures of materials that usually being used to make a concrete. We can see here this is chemical admixtures, and this is Portland cement, which is the most used type of cement. And this is another type of cement such as fly ash like cement. This is the water, the most important materials chemical to make a concrete. This is sand and stone, which is another aggregates to make a concrete. So this is the last part, which is the advantages and disadvantages of concrete. One of the advantages of concrete is economics benefits, long life and low maintenance requirements, resistant to wind, water, rodents, and insects. We can see here there are we can compare buildings which made by concrete and building which made by woods. The concrete is much more strength and stable, so it have a long life. It has long life. Concrete has the ability to be molded or cast into almost any desired shape on the work site. We can see here, yeah, we can make any shape that we want by the use of concrete and non-combustion material. Okay. The disadvantages of concrete are relatively low tensile strength, low strength to weight ratio, and susceptible to cracking. That's all from me.
Okay, so further improvement have been made to concrete to increase the strength of concrete. The first one is by using reinforced concrete. Reinforced concrete is concrete that contains the reinforcement in the form of rods, wire, or wire mesh. So if we recap back to the previous lesson by previous group, how material react to the internal force is by compression, tension, and shear. So concrete can withstand strong compression but cannot withstand tension. So how is it is used is by adding the rod wire inside the concrete before it is hardened, as we can see here in this video.
Known as rebar. I made a new beam with a couple of steel-threaded rods cast into the lower portion of the concrete. These threads should act just like the deformed ridges of normal rebar to create some grip between the concrete and steel. Under the press, the first thing you notice is that this beam is much stronger than the previous one. We're already well above the force that failed the unreinforced sample. But the second thing you notice is that the failure happens a little bit slower. You can easily see the crack forming and propagating before the beam fails. This is actually a very important part of reinforcing concrete with steel. It changes the type of failure from a brittle mode, where there's no warning that anything is wrong, to a ductile mode, where you can see the cracks forming before a complete loss of strength. This gives you a chance to recognize a potential catastrophe and hopefully address it before it occurs.
Okay, so that is how it is applied in the concrete. So the next one is using pretension and post-tension concrete. So pretension concrete is the steel, the rod is stretched before it is applied, it is put into the concrete. So when we stretch the rods, it will have tension to the rods, and when we put the concrete, will will so the concrete surface will have compression. So when the load is applied above the concrete, it will balance lah. Okay, post tension. Post tension is same as pre-tension, but in pre-tension we put the rod before we put the concrete. In post tension we put the rods after we harden the concretes. Okay, let me show you the video.
Concrete. Pre-stressing means applying a stress to the reinforcement before the concrete is placed into service. One way to do this is to put tension on the steel reinforcement tendons as the concrete is cast. Once the concrete cures, the tension will remain inside, transferring a compressive stress to the concrete through friction with the reinforcement. Most concrete bridge beams are pre-stressed in this way. Check out all that reinforcement at the bottom of this beam.
So that is the video how it is used for the pre-tension. And now for the post-tension.
In this method, the stress in the reinforcement is developed after the concrete is cured. For this next sample, I cast plastic sleeves into the concrete. The steel rods can slide smoothly in these sleeves. Once the beam cured, I tighten nuts onto the rods to tension them. Under the press, this beam wasn't any stronger than the conventionally reinforced beam, but it did take more pressure before the cracks formed. Also, this one wasn't quite as dramatic because instead of failing the actual steel rods, it was the threads on the nuts that failed first.
Alright, that's all from me.